is FAC's next session, which is going to be looking at operational and embodied carbon and the development of new standards as we go forward. To lead the presentation, we have Paul Foster from Auditel. So over to you, Paul.
Thank you, Alan. So this short discussion really is just to highlight how you can slash your building's carbon footprint in half, and it's a lot easier than you think. So why would you want to be doing that? Well, you can lower running costs hugely, and of course energy is so expensive these days, that's quite attractive. But even more attractive is you can increase the value of your building by about 6%. So that's according to BlackRock. Another statistic that's quite interesting is that 40% of global carbon emissions come from buildings. So it's definitely an area that you ought to be really focusing on. So what I'm going to try and do today is just to describe, I guess, the difference between operational carbon and embodied carbon, because they are two very different things, but they do all contribute to that big number at the end. So in order to slash your carbon's impact, you must focus on both aspects. You can't just focus on one or the other. And so let's talk briefly about operational carbon. What is it? Well, it's what's produced during the building's use. So, for example, heating, lighting, running your appliances. Whereas embodied carbon, on the other hand, is the emissions from the build or the refurbishment work. So it's more to do with the construction piece. So it's materials, transportation, construction and demolition. So it covers the whole life of that product or that building. PAS 2080 is the framework that is being adopted by building standards in the UK. It's a new standard that's being driven from the UK. It's a UK first. It will become an international ISO standard at some point in the future. And it helps you take care of that whole life, if you like, that whole life cycle carbon, both operational and embodied. So it's an important framework to use. Interestingly enough, it also improves efficiency within the building environment. So carbon's, I guess, the prime motive, but the benefit is that it improves efficiency all the way around. So reducing operational carbon involves energy efficiency and renewables. And it's amazing how many organisations over the years that I've spoken to do not look at the price of a widget or the cost of anything in minutiae detail. So overhead costs are where you find your energy costs. And of course, you don't really know what sort of impact you can have on reducing that, because you've never gone so far as to look at the granular level reporting on that. So there are things that you can do to actually get into the detail of operational carbon and how to reduce it. And of course, it's all around data. Reducing embodied carbon, though, is about, I guess, purchasing lower carbon building materials. So, for example, steel is a good example. Aluminium might be another. You buy something that has been produced in an environment that generates low carbon versions of. You can't tell the difference. It's just the way it's been manufactured, the energy that it's used, the transport that it's used, the recycled content that it's used. So I won't say it's easy, but I guess with certain categories of materials, steel, aluminium are good examples, cement's another, there is a way of reducing your embodied carbon by over half. So it's an area to look at. So let's just focus very briefly on operational carbon. How do we reduce it? Well, energy efficiency. And it's amazing how many organisations waste energy because they don't really understand what's using it. So reduce energy in manufacturing and operations is a good way to go forward. Switch to renewables. So by reducing your reliance on the grid, not only do you save money, but actually, whatever is being powered by that. So it could be a building, it could be a manufacturing facility. That will also reduce your embodied carbon. Things like slash water consumption. If you install low flow water systems, fix your leaks. It's amazing how many people have got leaking systems. The water companies have got that as a major problem all the time. But by the way, if you fix that, less energy used for treating and pumping water, for example, and there's capturing rainwater. So there's all sorts of things that you wouldn't necessarily associate with carbon. Upgrade for efficiency. Invest in energy efficient heating and cooling systems, for example. Invest in smart building automation systems. So when the energy is not being used or shouldn't be used, so for example, occupancy, time of day and weather conditions. So regulate your heating, cooling, ventilation and lighting to take account of, well, the weather and whether people are actually using something. So occupancy sensors are quite useful in hallways, restrooms, conference rooms, automatically turn lights off and other equipment when not in use. And you can also shut off power to equipment in standby mode, right? So that can significantly reduce overall energy. Basically, it's just having the right sort of equipment in place to spot what's going on. Conduct regular maintenance checks. Check your windows. Are there air leaks? Windows, doors, other buildings, envelope. Look at the infrastructure of that building. Appliance efficiency. I mean, if you're a manufacturing facility within your building, you've got a lot of equipment using huge amounts of energy. Are you actually understanding what energy is being used by what? In most cases, most companies don't. And that's an area that you really should do. You should look into that because you can make a big impact, not just on energy reduction and cost reduction, but also on decarbonising the products that come out the other end. So it's really it's about implementing a combination of these methods to save you energy and carbon. It's no one silver bullet. There's a lot of things here. So what's embodied carbon and how do we reduce that? Well, slashing your embodied carbon footprint really focuses on all of the life stages before design. In fact, you start with design, you then move to material sourcing, you then build something, you then use something, and then you've got the end of life. So the more you reduce, reuse, and recycle, the better it is. I mean, go back to the steel that I talked about briefly earlier. If you use a high recycled steel content and you use renewable energy and you use the right sort of transport, you will halve the embodied carbon in that steel or that aluminium. So it's not necessarily about the product itself, it's a combination of things. Refurbish, don't knock down. If you knock down and rebuild, you're creating a huge amount of carbon. So again, by looking at the whole life cycle, you understand that by refurbishing, you can actually salvage and recycle all sorts of materials. So there's benefits in that. Opt for low carbon materials. Go back to my steel or aluminium or cement. It's easy to get that sort of product, that low carbon product. Buy local. Transport contributes a huge amount to embodied carbon. And of course, lifespan matters. Choose durable, long-lasting materials. You don't want to keep replacing things because that also increases your carbon. Design for efficiency. Incorporate energy-efficient features during the design phase. Transparency is key. So this is where PAS 2080 comes in. It's a whole life carbon assessment that's been developed. There's whole life carbon accounting. So that's the same way as you would use financial accounting for a business. You wouldn't run a business without recording your sales, your costs, and your profits. I mean, your shareholders wouldn't be too happy. This is the same sort of principle. And at the end of the process, you've got project verification and certification. Now, this is really important because investors are looking for those low carbon solutions to invest in. And because of that, they want someone to verify what they're doing. So there's lots of organizations out there saying that they're going to do environmental stuff, and it all sounds very green, but actually there's no detail, there's no targets, there's nothing in there. And increasingly lenders want to understand what's going on. So there's an assessment process. PAS 2080 is ideal for that. It checks what the plans are, and then it checks what you've delivered at the end of the process. And of course, that can reduce interest rates. So that's really good for you when you're looking for investors. So the standardized PAS 2080 framework is really the core of all of this because it takes into account the whole story. So it's a holistic carbon management process, and it basically can be used not just for buildings, it can be used for all sorts of things, but primarily it's used in buildings, it's affecting building regulations, the government are adopting it because it's the right solution, and it's a good way to approach it. So PAS 2080 is a collaborative approach. And if you look at the construction industry, it's full of subcontractors and so on and so forth. PAS 2080, allows for all of that, and it helps you make better decisions. It helps you focus on where the carbon is impacting a building and where to focus to reduce it from start to finish. So it's the proper alignment with regulations and and I guess it's a valuable tool for staying ahead of the curve. So if you want to find out a little bit more, because it's a really huge, complex subject that I've just rushed through here to give you an insight into it, please contact the FAC. I'd love to talk to you about this in more detail, but as I say, it's a huge, huge area. Thank you.